15 years ago, something happened that changed human health forever. And it happened just a few miles from this very auditorium. It was at the Bronx Zoo, and what happened was a flamingo dropped dead. And then a bald eagle did too, and an Asian pheasant, and a cormorant, and a snowy owl, and a few more flamingos. And it wasn't just the birds at the zoo. At the same time, all around New York, crows began acting funny. They were seen hobbling along gutters, disoriented and dying. There were corvid corpses everywhere, on stoops and on sidewalks and in parks. An avian killer was on the loose in New York, and no one was doing a thing about it because really big deal, right? I mean, obviously it was sad that birds were dying, but these weren't human deaths, so the die-off went pretty much unnoticed, except by one doctor. Her name was Dr. Tracy McNamara. She was a general practitioner. She had a special skill and talent for pathology, and she loved a good medical mystery. So Dr. McNamara saw what was going on, and she gathered up some of those dead birds. She dissected them to see if she could figure out what was killing them. And what she found was massive brain hemorrhages, heart failure. It looked like viral encephalitis. It was summertime, so she thought to herself, mosquitoes. This could be a virus spread by mosquitoes. But which virus? Why birds? Where and whom would it strike next? I interviewed Dr. McNamara in 2010, and she told me at that moment she had a real stab of dread, because she realized that if this was a mosquito-borne virus, then it wasn't just birds that were at risk. Every warm-blooded animal, like say, I don't know, everyone in this audience, was also a potential victim. And sure enough, at that moment, a mystery illness began cropping up in ERs all over New York. The patients tended to be elderly, and they presented with classic symptoms of viral encephalitis: high fevers, headaches, confusion. When the patient count got high enough, the CDC sent a team to investigate, and they worked quickly and diagnosed St. Louis encephalitis, SLE, a rare but not unheard of virus, but was indeed spread by mosquitoes. Mayor Rudy Giuliani rolled out a multi-million-dollar mosquito abatement program. Some of you may remember this. There were informational brochures and free insect repellent and a helicopter that hovered over the city, spraying malathion on the neighborhoods below. Case closed. Dr. McNamara thought to herself, wait a minute, this isn't the end of this story. You see, Dr. McNamara thought the animal cases and the human cases might be related, and that meant that there was a problem with the diagnosis of SLE. And that's that birds don't usually die from St. Louis encephalitis. They can get sick from it, they can carry it, there are reservoirs for it, but SLE wouldn't cause anything like the avian die-off that was going on the streets of New York and at the Bronx Zoo. And how did Dr. McNamara know this? Because she wasn't a human physician. Dr. McNamara is a veterinarian, and at the time, she was the head vet of the Bronx Zoo. And that's when the stakes went even higher, because 2 of the human patients died. So Dr. McNamara called the CDC herself. She said, I think the bird cases and the human cases might be related. I have all this bird data I'd love to share with you. I'd love to work with you to figure out what this virus actually is. And what do you think happened? We have on the one hand the CDC, the premier research institute for human disease in the world, staffed by extremely talented people who tend to think they know everything, versus a zoo vet from the Bronx. Do you think they said to her, come on down, we'd love to hear all your theories? No, they didn't tell her that. What they said was, you're a vet. You can keep your bird concerns and your bird data to yourself. We're the CDC. We've got this under control. We know human disease. And Dr. McNamara told me later that she was offended or surprised, let's say, but luckily she wasn't deterred. So she called up an Army lab in Maryland, and that collaboration produced something startling. This was indeed a virus. It could travel between animals and humans with mosquitoes as the conduit. It was not SLE. It was a virus that had never before been seen in New York. It had never before been seen in North America. It had never before been seen in the entire Western Hemisphere. This was West Nile virus making its debut on a new global stage. So the CDC eventually took back its diagnosis of SLE, and it replaced it with West Nile virus. And a few years later, they issued a white paper encouraging physicians and veterinarians to work together a little bit more. And that hasn't happened large scale at all. But in the 15 years since 1909, all of us do know a lot more about zoonoses, these diseases that travel between animals and humans, like Ebola and SARS, and the influenzas that are named for animals like swine flu and bird flu. But an undeniable gulf remains between veterinary medicine and human medicine. And this gulf has historical roots, it has cultural overtones, but I have to be honest with you, it's odd because the diseases that you're treating are truly one and the same. I'm talking arthritis, diabetes, breast cancer, heart failure, fertility concerns, obesity, sports injuries, even psychiatric conditions we sometimes think of as being uniquely human, like anxiety and depression, even eating disorders, self-injury, and addiction. A couple years ago, I wrote a book called Zoobiquity. And in it, I look at the overlap between animal medicine and human medicine, and at this gulf that separates doctors who take care of animals and doctors who take care of the human animal. I wrote it with a cardiologist at UCLA, who also consults on cases at the Los Angeles Zoo. And what our research showed was that most physicians think that the only overlap between animal medicine and human medicine is an infectious disease. But infectious diseases are truly just the beginning. What I mean is most of you are or are studying to be cardiologists and pulmonologists and oncologists and OBGYNs. You are wanting to be or you are pediatricians and dermatologists and psychiatrists, or you're nurses and therapists and more, and so are veterinarians. Many vets are subspecialists in every one of these fields, and in addition to treating primates, like human doctors do, they also have to apply their knowledge to many other kinds of mammals, to birds, reptiles, amphibians, fish, even in some cases exotic insects. Vets have to be pediatricians, they have to be geriatricians, they have to be adolescent medicine doctors, and they have to do it all with patients who can't speak, at least in human language. In fact, vets have a secret inside joke that they will sometimes tell each other, which is, it goes like this. What do you call a vet who takes care of only one species? A physician. So let me give you a taste of some of these species-spanning possibilities. Tragically and prematurely, Steve Jobs died of what every news outlet called a rare cancer. It turns out that neuroendocrine tumors might be rare in people, but they're actually quite a common cancer of many breeds of dogs, including German Shepherds, and also of domestic and wild ferrets. It's interesting to think about what an oncologist studying that kind of cancer could learn from a veterinary oncologist who sees it every day. Angelina Jolie recently wrote an op-ed in the New York Times talking about the surgery she'd had to lower her risk of breast cancer that came from a genetic mutation called BRCA1. Well, BRCA1 mutations are not uniquely human. They've also been found in English Springer Spaniels and in large cats like tigers and leopards. And in those animals too, they're associated with higher risk of breast and ovarian cancer. So it's just interesting to ponder, when it comes to breast health, Angelina Jolie may have more in common with a Venezuelan jaguar than with her BRCA1 negative co-star or neighbor. Hibernating bears. Let's take heart health for a second. Hibernating bears are a health disaster waiting to happen. They're obese, they're sedentary, their blood flows so slowly it's almost still. For 6 months out of every year, they don't eat or drink, urinate, or defecate. That would kill a human patient. You used to find bears dead in their dens every spring from kidney failure and heart attacks and strokes and complications from diabetes. But we don't, and that's because nature has found workarounds for all of those issues. One of the most interesting is that they seem to be able to shunt their blood from their kidneys to their intestines during that period, where unique microflora may perform some of the thinning and cleaning tasks. This was a topic I didn't spend much time thinking about before I wrote Zoobiquity, but did you know that wild animals can get sexually transmitted diseases? They, when you think about it, are not practicing safe sex. I've never seen a wild animal condom. And they often have multiple partners. That's almost the norm. Koalas in Australia are undergoing threat of extinction, actually, from a chlamydia epidemic. And HPV is running rampant through certain kinds of dolphins and sea turtles. Again, it's interesting to think about what an MD studying hepatitis or HIV could learn from a vet who knows how these kinds of infections move through wild populations. And then if we take nutrition, if you'd asked me a few years ago, do wild animals ever get fat? I would have said, well, of course not. They're out there chasing their food, or they're being chased. They're exercising. Everything they eat is whole grain and unprocessed and maybe even organic and wild caught. But it turns out that given a certain amount of abundance, wild animals will eat past satiety, and they will get fat. They can get spectacularly fat in the wild. Of course, the big difference between wild obesity is that there's usually an endpoint, and that's seasonally determined. So the kind of eternal abundance that we have as humans is just not found in nature, and that might be one clue toward looking at obesity in humans. Did you know that intestines can expand and contract like accordions? There's a smooth muscle that runs the length of the gut, and that means that when the intestine is in its relaxed full position, it exposes more surface area and more nutrients can be absorbed. When it's in its clenched, tighter position, food passes over undigested. Essentially, it's nature's non-surgical, reversible gastric bypass. And it's the mechanism that allows animals to, who are maybe migrating or hibernating, or they eat on a gorge fast pattern, to rapidly upcycle or shut down their GI system and their caloric intake to respond to what's going on in their environment. Social stress can cause pigs to develop a self-starving syndrome that looks a lot like human anorexia nervosa. Social stress can also induce a kind of vomiting syndrome in beluga whales and gorillas that looks a lot like human bulimia nervosa. Are these identical syndromes when you're thinking about psychiatry? Of course not. But doing this comparative analysis and looking at where these things overlap can expand our definition and approach to behavior and biology. Which takes us to psychiatry. There's something that birds can get called feather plucking disorder, where they pluck out their feathers one by one. It looks a lot like human trichotillomania. It's also related to something that stallions can get called flank biting disorder, where they nip and nip at their own bodies until they bleed and then keep going back and doing it again. There's something that dogs and cats can get called acrolick dermatitis. Veterinarians sometimes call it over-grooming. It's where they lick and get injured and then keep going even though the wound hasn't healed. Vets are vigilant for this kind of self-injury, and they have ways of preventing it before it happens. They always look out for stress, isolation, and boredom, and they have strategies like maybe they'll take a self-injuring stallion who's lonely and alone in a stall, and they'll try to return him to a more normal social group. They'll try to return him to the herd. If returning him to the herd isn't possible, they'll give him an animal companion, maybe a little chicken or a goat, and that often will take care of the problem. There are birds that seek out fermented berries and fly drunk. There are wallabies that jump into opium fields and get high. There are rats that scale fences to get to marijuana plants. The overlaps really are almost endless. And what I think we're doing is leaving science on the table if we leave these areas unexplored. That's what can happen when the birds fly drunk. It's a lot like human drunk driving. So what could you do to yourself? Just adopt a zoobiquitous outlook. It's really easy. All you have to do is ask yourself, does the disease or condition that I treat or study occur in a non-human animal? If you feel like going the next step, you can take a peek at the veterinary literature and see what you find, or you could reach out to one of your colleagues on the other side of the species divide. That's something that my co-author and I have tried to do with the Zoobiquity conferences that we created. We bring together academic physicians and academic veterinarians for a day of species-spanning conversations about the same diseases in patients of different kinds of animals. Our next one's going to be in Seattle in November, with the University of Washington School of Medicine, School of Public Health, Washington State University School of Veterinary Medicine, and the Woodland Park Zoo. The format is that we have a morning of academic cases, and then in the afternoon we put everybody on buses with packed lunches, and the vets and physicians symbolically, and in some cases literally, link arms and go on walk rounds at a zoo or an animal sanctuary. We've held these conferences in Los Angeles and in New York, and they've also been held at Stanford and recently in Utrecht in the Netherlands. This was, our partner here in New York was the Bronx Zoo. This is our goal for each of these days. This shows the Dean of UC Davis School of Veterinary Medicine shaking hands with the Dean of the UCLA School of Human Medicine. So the bottom line is that our essential connection with animals is ancient and it runs deep through body and behavior. And I think it's high time that physicians join with patients and with veterinarians to think beyond the human bedside to jungles, barnyards, oceans, and skies, because the fate of our world's health doesn't depend solely on how we humans fare. Rather, it will be determined by how all the patients on the planet live, grow, get sick, and heal. Thank you.